everything I'm covering right now, I know I already talked about from the beginning. You need a mask. From the beginning. I talked about at the beginning of this topic everything that I'm covering right now. I know I did, but I blitzed through it before. Now I'm just taking my time. So I know I talked about it already. So execution flow of how the definition of a function and some code calling the function would work. Let's say you wrote all of this in a Colab cell. You could copy paste it. What's the flow? Well, Python will start at the first line of code there that says def Celsius to Fahrenheit. I just want to make sure I'm recording. I have a bad habit of not. Okay, looks good. It's going to see def calc Celsius, or pardon me, def calculus to Fahrenheit. And what it's going to do is it's going to say, oh, this is the definition of a function. It's on line 1, its name is that, it's the definition of a function. I don't actually run this code right now. All I need to do is know that this code exists. So if someone wants to call this function, I can do it. And I know where to find it. So it goes, and then it sees, well, everything there is in the function, and the first line of code that I'm actually going to run is line 6. It's going to say, okay, take the value 24, put it in the variable Celsius. Then call the function Celsius to Fahrenheit, give it the value of Celsius, do the number crunching, get the result back, because of course Celsius to Fahrenheit returns a value. So the value that's returned goes in the variable Fahrenheit. Then on line 8, we just print out the value of Fahrenheit. Remember, a function call goes like this. I need a volunteer to be a function. It's going to be the easiest thing you'll ever have to do. You just need to sit there. You'll be the function. Okay, I'm going to give you the value, I don't know, what was 24 Celsius Fahrenheit? It was like 68 or something? All right, I'm going to give you the value 0. Okay, you're the function, and you have a return, but you're expecting a parameter. So I'm going to give you an argument 0 that you're going to save to your parameter. So I'm here, catch. Okay, you got it. Now you do the number crunching to figure out what 0 Celsius is in Fahrenheit. It's 32. So you do that calculation, and then you're going to return that value to me. So give it back. All right, thanks. So now he returned that value to me. And what am I doing with it? Oh, I'm storing it in the variable Fahrenheit. So now Fahrenheit has it. And then I print it out. That's it. The return is a way to get information back out of the function. The parameters are a way to put information in. The return is what information comes out of the function. But like last time, not to be confused with print. Print just displays information to a screen. It doesn't really, it doesn't do any communication back and forth between the program. So then we finish line 8, we go down to line 9. Oh, line 10, 32 Celsius, put it there. Call the Celsius to Fahrenheit, give it the value. It jumps up to line 1, goes, okay, temp in Celsius is 32, do the calculation, return the result. The result gets stored here, print it out. So the execution of the program is kind of jumping around the line numbers. Like the execution goes, okay, 6, line 7, which goes to line 1, 2, 3, 4, back to 7, then to 8, 9 is skipped 10, 11, which jumps to 1, 2, 3, 4, 1, 2, 3, 4, and then it returns to 11 and then goes back to and then goes down to 12 and prints it out. It's jumping all over the place. That's what it should be. Any questions? All right. I just explained it. Great. So abstraction. We're not going to do this activity because we did it like last week. Imagine I told you to give me the instructions of how to cook pasta, but you had to, like, you were only allowed to use things like locate object, grasp with a limb, release from a limb, move limb to its location, and wait some amount of time. That'd be a real pain, right? Compared to how you would explain someone else to cook spaghetti. Boil water, add salt, and add your spaghetti, wait, I don't know, 10 minutes, whatever. That's it. And that's all you need to do to tell another human how to do it, because a human understands how to operate at that level of abstraction. If I were to explain to a human how to cook pasta with, like, locate pot, move limb to location, grasp pot, the human's going to think you're ridiculous. You're being crazy. No one talks like that. I could give you an algorithm to make pasta, make spaghetti, using those operations I listed there. I could do it. And I could also give you an algorithm to make pasta by just telling you to boil water, add salt, and add your pasta, and wait. Both are valid algorithms, but they are described at entirely different levels of abstraction. We could get even more insane than those. We could start talking about neurons firing and ion pumps and all of this in terms of how to make pasta. We don't, though, because that's ridiculous. We, as humans, like to operate at a certain level of abstraction. If I go too abstract, you're not going to understand, right? Imagine you've never made pasta before, and I say, oh, boil water, do this, do this, do this. You're going to be like, whoa, 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 hold on, how do I do that? Right? Because maybe that was too abstract. But we operate at a certain level that we're happy with. Computers, depending on what they're doing and whatnot, might be happier with a different level of abstraction. Go back to thinking of the print function. I know I said this a lot already. The print function. It allows you to display information to a screen without having to worry about what the character looks like, what pixels to turn on, how to turn on pixels on the display, what happens if you move the display in the display. You don't need to think about that. And thank God you don't, because that'd be a real pain. All you want to do is print stuff out, so I print stuff out. Great. You get to operate at the level of abstraction of, go print this, and then it works. When you raise your hand if you drove your car here today, great. And when you got into that car, you didn't need to think about pistons firing and anything else, and the timing and any of the belts or anything about your car, because all you needed to do was sit in it, turn it on, put it in gear, and go. Because that's the level of abstraction that you're dealing with. When we're writing programs, we get to make up our own higher levels of abstraction. I can tell you to calculate the temperature in Fahrenheit from a Celsius value, and you could go program it as, okay, I take C, I multiply it by 9/5, and then add 32. Great. You could do that. That's one level. Or I could give you a function that I promise you will take a value that's a Celsius temperature and return a value that's Fahrenheit. Now, you don't need to think about, the value times 9/5 plus 32. You just call the function and give it the value, and it gives you the result back. Done. You are now operating at a higher level of abstraction. If I tell someone in real life to convert a temperature from Celsius to Fahrenheit, I would just say to them, hey, here's a temperature in Celsius, tell me what it is in Fahrenheit. And that would be enough for you to know how to go figure that out. I don't need to say to you, take some Celsius value, multiply it by 9/5 and add 32. Because it's too much detail. You don't want that detail. You can operate at a higher level of abstraction. And in programming, if we can add a level of abstraction to go from the basic calculation to just a function call, we could keep doing that over and over and over and over again to keep operating at higher and higher and higher levels of abstraction. Raise your hand if you read through assignment 1 already. A couple of you, right? Maybe a quarter of you. At the very end, you're going to have a function call that says calculate the density of Starbucks in some given area. That's the function call. So at the end of the day, after you're done that assignment, if you ever want to know the density of Starbucks in a given area, you just call that function. Now, that function doesn't exist though. It is your job in the assignment to write, along with all the other helper functions that will go along with it to make it do what it needs to do. The first time you write it, of course, you are starting from this level of abstraction, but you're going to write a function to solve part of the problem. And then you're going to write another function to solve part of the problem. And then another function to solve part of the problem. And then you're going to use this function and this function together to solve this part of the problem, and then take the result of this one and do... You build those layers of abstraction up. When you're writing it for the first time, you're going to need to do the calculation of area. You're going to need to count how many Starbucks are in the specific area. You need to write that code. But after you wrote it once, if you ever want to know the density, you just call that density function because you've set it at a certain level of abstraction. But I want to emphasize, you're going to be creating levels of abstraction. And it's kind of funny because I can talk about a bottom-up approach of abstraction where you start with this and then you make it a function and then you use that function and make another bigger function and so on and so on and so on. Bottom up. But a lot of times when it comes to solving problems, we start at the top. I know the problem I want to solve. And then you end up having to actually break down. So it's a top-down approach where you know the problem you want to solve, and then your goal is to go, how can I break this down into a lower level of abstraction? And then even lower, and then even lower, and then even lower, until you get to the level that, oh, I can write 2 lines of code to make that function. Great, done. And then you can work your way back up. As we're starting, we're going to take the bottom-up approach because I'll tell you what to do. But as we move forward, I'm going to say, great, I need you to write a program to do this. And you're going to go, how? And I go, figure it out. And then you start with what the end goal is, and you have to break it down, break it down, break it down, break it down, and then start solving those problems to finally solve the big problem. But as of now, I'll start with, okay, do this, and then you're going to use that to do this, and then you're going to use that to do this. Because we got to start somewhere. I can wave my hands a lot about abstraction, and your goal is to learn how to get good at making good decisions on what things to break in half and put together to make higher levels. Finding those layers of abstraction is a really important part. It's a really important skill you have to learn. I can't teach it to you. It's like an art more than a science. You just kind of get a feel for it. You are not going to finish this course and become an expert in how to do this. You're not going to finish your computer science degree and become an expert in how to do this. This is something you will never be an expert in because it's something you will always be developing throughout your careers. You're already pretty good at it in real life, but that doesn't always translate really great to the program. So it's a skill you're going to be developing in. You're not going to be great at it. You're not going to be terrible at it. There's always room for improvement, and you're always going to be improving. Don't expect to be an expert. Expect to struggle with, how do I break this down? Is that the right way to break it down? Honestly, a lot of times there's no answer to that question. There is no correct way. There are multiple ways that are just fine. Which is the best? I don't know, flip a coin. So be aware. So we talked about specific functions. We talked about calculus, or Celsius to Fahrenheit, and square of sum there. But I want now, can I help you?
No, we're just showing them catfish.
Cool. So I want to talk a little more general about what on earth the rules of the functions are. I showed you 2 specific ones, and maybe you can generalize from that, but to just hit really clearly, here's the general idea. Def is the first thing you need. Def means define. We're starting to define a function. Def tells Python, oh, they're about to define a function. So Python sees def and it goes, okay, what is it? You give the function name. You can make it whatever you want. Same rules as variables. You know, can't start with a number, make them all lowercase, it's multiple words, have underscores. Some of those are hard rules that Python makes you follow. Some are conventions that if you don't follow, everyone makes fun of you and hates you. Then you have an open parentheses, and you have your parameter list. Your function doesn't need to have any parameters, right? You used import, or input, right? And you just had open, close. You didn't put any parameters in there, that's fine. You don't need to have parameters. Sometimes you do. Sometimes you need 2, sometimes you need 7. You can have as many parameters as you want. You name them what you need to name them. They're just like variable names. You separate them by commas, And if you need 4 parameters, you'll have, the first, second, third, fourth, and then you're done, close parentheses. So the parameters you want are between the parentheses. Then you have a colon. Raise your hand if you've written a function and you forgot the colon. Me too. And then you're like, why isn't it working? It's totally right. There's not. Oh, right, yeah. How many of you did that? I did it. Yep. So we have the colon. The colon's very important. And then immediately after that colon is where we start writing the statements we actually want within the function. But those statements have to be indented. Raise your hand if you started writing a function and forgot your indents. And what did it say to you? Like, oh, unexpected, it got mad, right? It didn't work. So you have your indent. Every statement you want inside the function will be indented at the same level. We'll learn about more indentations later. But you want everything at the same level. And then when you're done, and you want to continue writing code, but that code you don't want in the function, you unindent and just carry on. And I'll scroll up just to show you the example we saw before. See? Def, colon, 3 lines are indented. That's the function. And then the code outside the function is unindented. That's it. You do not need to have a return statement at the end. We often do. But if your function truly returns nothing, and you don't need to write a return statement, Python adds one for you whether you like it or not. You won't see it, but when it's running, it adds a super secret return statement that says return what? For those of you that were in lab yesterday, you know this for sure. Return none. None is that super special value. It has its own type. It's not an integer. It's not a string. It's not a float. It is of type none type. And it can only ever take on the value none. And all it is a flag value that programmers use to indicate nothingness. So, and that's fine. That's fine. You're not breaking any rules with that. If you have a function call and there's no return, think about print. See what happens if I do this. None. The print function displays information to the screen, but the print function has nothing to return. So Python just says, okay, well, you return this special value that means none. And then I print it out. Well, what did the result of print give me? And it was none. I mean, I could keep doing this for fun. What do you think will happen if I do this? Or this? No, right? Why would you do this? You wouldn't. But often, here's how you know if you find yourself a couple of weeks from now going, well, based on the rules I know, can I do this? And then you do it, and it does it, and it works. That's how you know you're probably a pretty good programmer. Can I do this? Can I try to break this? Oh, it worked? That's good. Do that type of stuff. Follow that brainwave. The reason this is ridiculous is, well, why would you want to print out 5 and then print out the result of that print and then also print out the result of that print and then print out the result of that print? Why? Just because. There's no utility in this that I can think of. All right. Function name, blah, blah, blah. Okay, we're going to give you a quick activity here. I'll give you a couple minutes to do this one. Remember, to concatenate strings, you just use the plus between strings. So here's an activity. Write a function, concatenate strings, that takes 2 strings as parameters and returns the concatenation of those strings. You might find your function is like 1 line long. That's fine. But make this function. And then when you're done, and you're happy with its execution, jump to the next activity. The next activity is write a function that takes 4 strings and returns the concatenation of string 1, 3, 2, 4 in that order, based on the parameters. But you are not allowed to, within that function of Crisscross Concatenation, you are not allowed to use the plus to concatenate strings directly, but you are allowed to use, what was it, cross concatenation? Or strings? You are allowed to use concatenate strings. So take your time with this. I'll give you a couple minutes to do these two activities, but I will stop after a couple minutes to just talk about the first one before we really move on to the second. I would say this is probably the first, this is the most complex function you'll have to write so far. Any function we've done so far is not as complex, so if you're struggling with it, you're normal. But it's important to know how it works. Oh, shit. Raise your hand if you got the first one done. Raise your hand if you'll have the first one done in like just 1 minute. Cool, keep at it. something effectively identical to this. Concatenate strings. Well, to concatenate strings, all you have to do is the plus. So, I write the function, I define it, concatenate strings, give it two parameters, and then I simply just return A plus B. I could have done it in an extra line, like this. Oh, no. There, it'll also work. Who here did it with the third variable? Well, yeah. Both are entirely fine. Arguably, you can make, I suppose you can make an argument that one's better than the other, but they're really not. So here it is. Did anyone get stuck on this one? And if so, where? Because let's see if we can figure it out. Yes?
Mine says unexpected EOF while parsing.
Are you missing a parenthesis?
Brackets.
Yes. Do you have an open but missing a close?
Oh.
Was I right?
Yep.
Usually, it's a parentheses thing when it says like end of file. Sometimes it's also a quote. If you're missing a quote, you'll get something similar.
Yeah, I just had like print and then my find function and I didn't throw on the second bracket.
Like that, yeah. And see, if you did, let me guess, because you had this, and you had the one close, but not the second close. Very common mistake. I make that mistake. And then I just go, oh, if I'm missing it, I'll go, oh, I probably have one too little. And sometimes I just play this game because if you're nesting function calls and function calls and function calls and function calls in the parameters for like arguments, you might have where you have like a bunch of these at the end, and you're left going like, is this enough? No. Is this enough? No. Is this enough? And so on. So it's a common mistake. If you have too many, it'll just say invalid syntax. The error EOF, unexpected EOF while parsing, what it means is Python saw an open, and it's expecting to see a close for every open. It has to. But it found an EOF, the end of file, before that last one. That's what that means. Again, like I've been saying, you'll get used to these error messages soon enough that you'll be familiar enough to be like, oh, that's probably a parenthesis or something. If I do that, see, EOL while scanning string literal, end of line, before it found the actual end of the string, the close quote. So, there. Cool. So, that's one function. Now you have to write another function. Crisscross concatenation. A, B, C, D. And note, you can reuse the variable names. I'm reusing A down here, and it's already up here, but that's fine because I kind of talked about this already, and I'll talk about it more after this, of something called variable scope. When I define a variable A within a function, that variable only exists within that function. So it's fair game in another function. So you need to do crisscross concatenation, where if I were to do it the wrong way, I would do something like this. Return A plus C plus B plus D. Right? Because it wants the first, the third, the second, and then the fourth. So this would be the wrong way to do it. It's correct, but there was the constraint I gave you. You're not allowed to use plus to concatenate your strings in this function. That's the rule. So although, here, let's just check the results. And I'll just do like A, B, C. Because it'll be easier to just check, print. A, C, B, D, yeah. So it should be the first, the third, the second, the fourth. Great. So this is working because I just concatenated the first and the third and then the second and then the fourth. But I'm breaking my rules. I am not allowed to write plus in that function as I'm writing it. So you're left going, yeah, but plus is the operator I would use to concatenate two strings. You're right. But don't you worry. I've got a great function for you that'll do that for you. And that function is called concatenate strings that you just wrote. And what does concatenate strings do? It concatenates strings. In fact, you don't even need to know how concatenate strings does what it does. All you need to know is that, well, if I call the function concatenate strings, I give it two strings, it returns the results of them concatenated. In a similar way that you don't need to know how the plus sign does what it does. All you needed to know is that you can say a string plus another string gives you the concatenation. Great, but throw that plus away and now use concatenate strings to solve this problem, to write this function. Raise your hand if you're done this one. Raise your hand if, yeah, you need a couple minutes. Okay, well, I'll wait a couple minutes because this is a good one. If after we talk about it, you're still a little stuck with it, take your time with it. There's also a video here going over how it works, so don't, there's resources for you to learn it. But this is an important one. For those of you that are finished, did you have basically this? More or less? So how did it work? Well, I'm not allowed to use the plus. If I was, I could do it like this. I would just say A plus C here. Unlike before in the previous one where I did it all in one line, I'm breaking it up now. And then here, if I wanted to concatenate the second and the fourth, well, that's just the B and the D, so that's B plus D. And then if I wanted to concatenate the remainder, well, that would be the first, third, plus second, fourth. And if I run that, we get A, C, B, D, which is correct, but again, this is breaking the rules. Instead, I call the magic function concatenate strings that I know if I give it two strings, it returns those two strings concatenated. That's what it does. So I call concatenate strings and I give it the two strings I want concatenated. The first and the third. The first, which is A, and then the third because that's C. And why is it the third? Because it's literally the one, two, third one. And I know that gives me the concatenation of A and C. And I'm going to store it in a variable called first third, because why not? Then I want to concatenate. And there are different orders I can do this. There's nothing saying I need to do it this way. If I wanted, I could have concatenated first and third with B. And then changed this next line. But we'll keep it simple. So second and fourth, well, that means I want to concatenate B and D. So concatenate strings B and D, stored in second, fourth. So now I have the first and the third, and then the second and the fourth, and I want to stick them together. If only I had a function that can concatenate strings. Oh, right, I do. So I concatenate the strings first and third with second, fourth, store it in full string, return full string. Boom. I can guarantee that if you're really struggling with how this worked, you're thinking too hard. You are trying to connect dots that don't exist. You're thinking at a higher level of abstraction. You're looking for some key element you missed. You missed nothing. The trick is, what does the code say? When in doubt, follow every line of code one at a time. Make no assumptions. That's the one trick to learning programming. What does the code say? And consider the execution of this cell. Python starts at line 1 and goes, oh, okay, it's just a function definition. Concatenate strings, I'll remember it exists. Oh, here's another, on line 5, another function definition. Okay, great. Oh, on 11, I call the function Crisscross Concatenation. So on line 11, I then jump to line 5. Go inside this function, go to line 6. Oh, Crisscross Concatenation calls the function concatenate strings, meaning I now jump to line 1. Then I do line 2, line 3, return to line 6, go to the next line. Oh, concatenate strings, go back to line 1, 2, 3, return to line 7, go to line 8. Oh, concatenate strings, 1, 2, 3, return to line 8, go to line 9, return to 9, or return on line 9 goes to line 11, stores the result in results, and then prints out the results on line 12. We're jumping all over the place. But that's how this works. It's just following what we said to do. How was I supposed to know that, if you're wondering? You're thinking too hard. You were supposed to know that because it just says, call the function Crisscross. Oh, that means we go to that function. There's no more magic than that. One line at a time. Do not try to connect dots that don't exist. Don't think too hard. Really, I can't stress this enough. And when I say don't think too hard, I don't mean you're like literally sitting there going, I'm thinking. I mean, you are expecting there to be a magic trick you need to learn. You're expecting there to be some magical idea that you just must have not been paying attention and got. No. What does it say? Don't think any higher than that. What does it say? Questions about crisscross concatenation? Yes.
Why do you use a print?
At the bottom here?
Yeah.
Because if I don't see the final result.
But like, you don't have to put into it.
Pardon?
Do you have to put into a variable in the first place?
Well, if you do this without the variable, it's not really printed out. I know you're going to say, oh, it says AC is printed out. It's not. This is Python. This is Colab just kind of saying there was a dangling value. If you submitted this and I ran this program, I would see no output. This is just a consequence of Colab. And you can tell there's actually a difference because notice how this string here has the quotes. If I do it without it, there's no quotes. Print works very differently than that. So why is the print there? Because if you want to print something out, you write print. Just as I showed you, if you want that, like if you called that and returned a value, you're going to want to save it somewhere. And if you save it somewhere and you don't print it out, there's nothing coming out. So you need the prints if you want to print anything out. All right, composition. Well, we just did it. You can have function calls. You can have functions call other functions that call other functions that call other functions that call other functions. We just did an example with Crisscross Concatenation calling Concatenate Strings. There's nothing stopping us there. And because often the functions return a value, I can write an expression like this. Square of sum 2, 2 plus square of sum 3, 3. And you're like, well, you're adding functions together. Well, no, not really. I'm adding the results of those functions. Because I would go in to square of sum 2, 2, calculate the result. Well, the answer to that is 16. And I would also do square of sum 3, 3, calculate the result, that's 36. So really, this whole expression means 16 plus 32, which is 52. So you're not adding the functions together. We're calling these functions, and these functions get crunched down to a single number, that value that's returned, and you can use that in your expressions. Similarly here, you can put function calls and function in parameter lists. Square of sum, square of sum, square of sum of 3, 3. So I called square of sum with the two parameters, which will be the results of square of sum 2, 2 and square of sum 3, 3. Well, that's square of sum 16 and 36, which is square of, well, that's 2,704. So this is all legal because the function call, remember, we're calling the function, meaning it goes in, it executes, and it returns a value. The value might be none, it might be a number, it might be a string, so it depends on what you're using. But when the function's done executing, it brings back a number. So we can do this. Just like in math, we can do, if I had like f of x equals x plus 1, I could ask you, what is f of 1 plus f of 4? This is the same thing. Well, f of 1 is 2, and f of 4 is 5. Well, it's 7. It's the same. So if this was scaring you, you're thinking too hard. It's not anything more magical than your grade. When do you learn functions? Seriously, who remembers? When do you learn functions? Grade 10. Grade 10? I always thought it was earlier than that, but it's been a while, so I'll trust you. So you've been doing this for a couple of years, right? So it's not new. Like I said before, if you're struggling with this, slow down. You're thinking too hard. Take your time. Follow the code. What does it say? Functions get evaluated and turn into values. If I gave you something like this, what is the result of all this? You could do this calculation with a pencil and paper. You don't need to give these values to Python to calculate. If you know what square of sum is, if you know what that function does, and I gave you this big long expression, you can calculate it with a piece of paper and a pencil. And if you don't believe me, do it. Because you can. Take your time. What does the code say? Follow the code. There's no other tricks to it than that. And then I already talked about variable scope, but I guess we'll blitz through this on Tuesday. So I'll see you later.